they have a tendency to stick together, to clump, and to agglomerate. And if you think about when you put that protector, that screen protector on your cell phone, there's no adhesive. It's just something that is very flat, very smooth, that connects with something else that is flat and smooth, and it's essentially there forever. And that's a challenge on the micro scale, and that's even more of a challenge on the nano scale. When you have things this small and smooth, when they stick, they clump. And when you are using an additive as a nanotube and you're putting that into other materials, when things clump together, they create flaws. And when they create flaws, they create failures. And the agglomeration problem is one of the main challenges that has plagued nanomaterials. So as we were developing our technologies, we knew that this is something that could not be smooth on the surface. And to take that a step further, if you are trying to use nanomaterials to reinforce other things, if you think about that drinking straw analogy again, and if you push that drinking straw into a clump of Play-Doh, you can push that straw in and pull it out very easily with almost no resistance. So there's no lock-in. There's no tendency to really be a reinforcing material. So we had another piece of evidence that said we must not be smooth. And challenge to mix these materials also has to do with the surface chemistry. And many times you have to change that surface chemistry of a nanomaterial to get it to be accepted into the host. And a lot of times changing the surface chemistries in such a way has a reaction that scavenges electron or scavenges atoms. And if you scavenge an atom from something that is essentially one atom thick, you've created a crack or you've created a void. And just the simple drinking straw analogy, again, if there's a hole or a crack in the straw, it doesn't work as well. It doesn't work as intended. So we also knew that we needed to create a surface that could provide sacrificial atoms.